Good afternoon. You can find a seat for those who are standing. The topic is second level monitoring of Trillion-yuan transaction. When I look at the word second, I'm nervous because yesterday I was doing the testing. When the number is changing on the screen, I was so nervous. I joined Alibaba in 2008 at B2B. I have created the first CMDB of Alibaba, and I've been working in the operation team, participated in development of many operation platforms. Now I'm responsible for monitoring platform of Alibaba. In the past, Alibaba, similar to other companies, we use mature solutions, Negos plus Cacti. This is classic, but it also has its problem. When your scale goes up, it's very difficult to solve the problem. Our machine scale was very small, nothing to mention. When it reached 10,000, the architecture had some problem. Now machine scale has been mentioned by Shu Tong. The original architecture was not working a long time ago. From 2009, we started to develop our own monitoring system. For the first generation architecture, it's still practical. It's a typical double-layer architecture, agent and master DB. We used MyCircle for storage at that time. We don't have so mature non-circle service that are available, so we only use MyCircle. It's very difficult for financial system. You have to create tables or database for some high volume. We have created our own agent system. The system becomes the foundation of our operation platform. Let me tell you about some unexpected achievements. We have accumulated several tools. Fast JSON, if you handle with Java, you might know that. And also Joy and Star Agent. When we're creating the first generation of monitoring system, our architecture of the monitoring system has. So actually, these are two most popular open source tools for Alibaba. FastJSON has helped us to solve the data transfer of the monitoring system.
And currently, on the GitHub, we say that we need to establish a monitoring system for the databases. We need to solve the problems for database monitoring, such as the circle statistics. And the last one, SlideJet. And as I have mentioned, we have constructed the total agent system, and this Star Agent had become the fundamental base level system for operation in Alibaba, and we have a lot of distributions of the documents, and all of these are based on the Star Agent system, and the original architect and realization of Star agent is derived from the previous architect. And now I'd like to introduce the latest version of our monitoring system architect. And at the very beginning, we only support minute level and a lot on 5 minutes level. But today we will support the second level. And this is monitoring for the second level. This is a very big improvement. And on this architect, compared with the previous one, there is a big difference because we have a circle here. It means that in the previous architect, there is no concept of tenant. And in the monitoring system, with the development of the businesses, we will have a mutation. For example, today, there is a special sale and a special offer. Then the monitoring system will be affected greatly. So we need to have a separated treatment for the tenant. To today's scale, maybe the A business and B businesses are in the same system, but you need to isolate A and B, because if there is no isolation, then A's failure will affect B. And the core business, such as transaction, will have a separate system, and it is isolated from the other systems. And in this architect, there is also a distinct feature with the other competitors. The core idea is that we need to pull up the data, and unlike the other monitoring system, they push up the data. So we pull instead of push, and this is quite different from the other monitoring systems on the market. And most of the systems on the market push the data. For example, I can distribute a sustainable exchange, and they are pushing up the data all the time. So later on, I would also explain why do we need to adopt such a different method. And our storage is H-based and the low circle technology-based. And we will also have some of the other configurations. And the pink part, we have the Apsara, and it is an operation system to manage this monitoring system. And later on, I also need to explain why do we need to do that. The challenges we have faced mainly include the 4 aspects here, because for the monitoring system, we need to solve 2 major issues. The first one is that how can we identify the problem once there is a failure? This is the most basic capability of the monitoring system. The second one is that after you have identified the problem, now you think that this is the minimum requirements for the monitoring system, and then you need to provide all types of the data and to tell the users what is exactly the problem. For example, there is a 2% drop of the transaction volume, and with such a big scale in Ali, it's very difficult for you to identify the problem. We also need the speed and accuracy, and apart from these, we also need the stability, because the monitoring system will monitor the whole business in a group. And in Double 11, it's very pronounced, because before the monitoring system always go wrong. Once there is a problem in the monitoring system, everyone will shout out, the monitoring is done, and they cannot continue until the monitoring system is operating normally again. So we must guarantee the stability of the monitoring system, and accuracy, needless to mention its importance. And apart from these preconditions, we need to lower the cost as much as possible. And now we are not very good at it. And later I would also talk about the cost. Let's move on to the scale. We have the tenants, and today we have over 80 tenants. And we also have over 3,000 machines. And this is the number for this monitoring system. And this was the data before Double 11. And I believe that in this year's Double 11, the number will exceed this. And I cannot tell you the exact number today. And we have over 7,000 applications. And every minute we can process over 1 T data. I'd like to simply talk about how we can solve the 4 problems. The first one is the speed. We need a very fast reaction, and we have done something to improve the speed. In the monitoring system, we have 3 layers. We have the centers and the distribution of tasks, and internally we call it the brain reduce the gap, and the brain will produce the tasks and a map. You could imagine it as mapping data A into the access log, and the access log may be one request, which is in one line. Then you need to calculate the total volume, and then the total volume will be 100. This is called map, and then we will reduce. So all of the data from different machine rooms will be summed up. So there are 3 different layers, and in a server, we need to do these 3 major things. The first one is the heterogeneous of the total links. With such big stress, any synchronized area will have a performance issue, and we also need to delock the core chains or core links. So these things are not too difficult, but the benefit is very huge, and we can greatly improve the availability of the machine. And the most effective practice to speed up is preload. It's very easy to be understood, and it has a very good effect. For example, we need to collect the data at 10:45, and as I have mentioned, we are pulling up the data. So if at 10 o'clock you pull the data, then it will consume a lot of time, especially for the second level data. For example, I need to collect 10:00 second, and when you calculate what kind of data you need to collect at that time exactly, then you will consume a lot of time. So you need to do it in advance, and we could directly distribute it into the agent, and you can wait. Once the time had arrived, I would start instantly to collect the data. There is almost no latency, so this is quite straightforward, but the result is really good. On a client, we have a very large volume. Per minute, we will process over 1T data, and now we may even process more than 1T data, and we have done several things on the client end. We need to make sure that the client will not affect the business system's performance on the machine, and we cannot allow the performance to be affected because of the monitoring systems. If it happens, we'd rather to get rid of the monitoring system. So if we have mounted the monitoring system on it, we cannot affect the client, and that's why we have conducted the zero copy. And once we have pulled up the log, it will not go through the CPU, and it will directly be pushed from the gateway to us. And this is also a very simple technology. But we need to have a trade-off. The transmission volume is relatively high, and we cannot have compressions, so the transmission volume is quite big. But basically, our current application is more sensitive to CPU and less sensitive to gateway. That's why we can adopt this measure. We also have the random access file. We will dynamically identify the time point, where exactly is the time point of 10 o'clock. Then we can dynamically abstract this time, and we also have the dynamic binary method, and we are increasing this time period. So suppose that the log started at 10 o'clock on that day, and maybe the denominator is 24 hours, and the numerator is 10, then we can conduct the calculation. So as for accuracy, we have conducted two things. The first one is from the design perspective. So why do we need to pull up the data? Because when you are pushing up the data, it's very difficult for you to guarantee that all of the data are pushing up by all of the machines. You need to make a statistics of how many machines are not pushing up the data. But it's different for pulling up. In advance, you will know that how many machines are pulling up the data. And you could make all of those statistics. And that's why, in the end, we can tell the users what is the completeness of the data. And the benefit is that once there is a problem, we will send a message, and we can tell user the concept of the complete degree, because we have a very large scale, and if the traffic had been reduced by 20%, and if we say that the complete degree is only 80%, then the user may believe that maybe it's not because that the business system is problematic, maybe is because one machine room had been down, and maybe it's because of the network problem, but their business level is still operating smoothly. And we will tell them that we have lost 20% of the data, and they can try to identify the problem. And from the perspective of test, we have conducted two core things. The first one is the accuracy return. Because we use the tenants, so we will have a real-time verification of the accuracy, and this is the accuracy regression. And we will have a real-time verification, and we can check whether the data is correct or not. And sometimes we cannot identify the online issues, and we really need a real-time verification for that. And we will also have our own log logic, and for every transaction we will have our own transaction log, so we could verify the real-time features of every tenant. And maybe each tenant will have different versions. As I said, we have over 80 of those tenants, and we need to have a real-time check for each of the tenants. Stability is the area that we have spent most of the time in the monitoring system. And I'd like to briefly introduce this aspect. The first one is the selection of host for the brain, and this is the core aspect for us. We could not allow any downtime, and there are several ways to guarantee it. The brain can never be done, because if the brain is down, everything else will be down. And we have done a very simple thing. That is to select the host through the peripheral equipment, because if you do it internally, then there will be a lot of issues, and if you ask another equipment to select the master or host, it will be much easier. So we have deployed the equipment in 3 machine rooms. And in the middle layer, there are a lot of failures. So many failures had occurred. How can we solve this problem? And it's impossible for us to write a program for each of them. So we have take reference from an industrial framework called ACA, and we have realized a similar architecture to ACA to solve this problem. The most core concept is that it's task-based. The benefit of it is that we can redo the task, and we have layers of protections for the tasks. So reduce can protect the latter, and the latter can support another layer. So it's layer by layer.
And bad thing about push, sometimes you don't know whether you need to push it again, but for pull, I know it doesn't work. I have the chance to do it again, and you can also rewrite the program, so it is usable. I will skip the other two. I'll talk a little bit about this. Why I'm talking about pull is because for Double 11, the lock is Maybe you can have 1 gigabyte per minute. If you're trying to push or pull, the center will be chaotic. When you're doing the pull, you know whether you have the ability. Maybe you will pull less, like you can pull at 50 gigabyte. And you need to do that for hundreds of agents. So that is the advantage of pull. If you know it's not possible, you will pull less. Cost. Cost is not avoidable. We have so many machines, so the cost will be high. But it's lucky to run such a large cluster. But for the companies, of course, they want the machines to be as less as possible. So now machines already reach a level of the medium internet company size. One obvious thing is the scheduling between the leases. So among the 80 leases, we cannot have campaign for all the 80 leases, like for June 18 or Double 11. For June 18th, like all the Navy, they don't need to get involved. And for the redundant machines, I can shift those machines to the other leases. And after that day, we can move it back, so the cost can be significantly reduced. This is the most obvious change. I'll skip the two in the middle. Those are routine. And the last one is the statistic value priority. Maybe there are 100 lines of certification. Maybe one number is 100, so we'll push the 100 line to the center, and we can point out the count instead of push it to the center. This is the prioritize the statistical value. So when we are setting the statistical item, we need to have the concept of the statistics. We also have our alien metrics, which is equivalent to the metrics in the industry. We are still trying to launch that. Maybe next time we can talk about that. Technical selection. I have said so many things. Why pull and push? Do we need to have our agent? Whether it is on server, on client, open source, or a self-developed framework, MySQL or Access TSDB or self-ops. It depends on the scenario. Technical selection is the balancing. If you choose A, you will lose B. For a lot of choices, for a specific scenario, you need to make a decision. It's not that which one is the best. It depends on the scenarios. Our direction, there are several directions. What we are doing is, for all the indicators of this financial system, we will try to standardize as far as possible. All the standardized indicators, configuration and alarming will be automatically configured. Another thing is about integration. Because you have dock, you also need to focus on the host machine's problem, whether other dock has lead to problems of your dock. These are the things we need to pay attention to, and also network and CDN problem. All these problems need to be integrated in the monitoring. If you miss any of the data for Dingding, you cannot identify the issue. And what we spend a lot of time is intelligence. It's a must. AI technology is so popular, so I think it is a must instead of providing some additional features. I will quickly introduce several interesting things. For the monitoring system, we not only have one, we have multiple monitoring systems, but this one is the biggest. We have created one MQL, monitor query language. What have we done here? For all the monitoring systems, the monitoring query, we used MQL to describe that. For example, we want to see the CPU utilization and maximum loading from the system, so we can use and select average CPU utilization, max load, load 1. You can expand its semantics. You have all learned about circle. Everyone knows how to use it. It's very intuitive. You don't need to add clustering things. You need to develop a new KPI. With this thing, you can continuously expand it. And if you want to draw a picture, you can just add the picture format. It can push you a picture or HTML. And this year's W11 data will be queried with MQL. Another thing, because we have Dingding, we have tried a lot of things. One trial is have alarm push, and for SMS, the biggest problem is that it is not interactive. If you want to rate the alarm, you cannot do that. When you receive the SMS, you cannot reply an SMS. Maybe you can do it, but the cost will be high, and it's not very interactive. But with this, we can do that. For a lot of alerts, more warnings are sent to Dingding instead of SMS, because we can say Dingding has zero cost compared with SMS. This is a snapshot of Dingding train, and we can send an alarm. You can check the details. The red lines means the time of the alarm, and we can see whether the trend has any problem. And you can close the alarm if you know about it and you are processing it. And for the 3 points, you can expand unlimited functions. You can click them and tell the monitoring system that you can clear the lock. Intelligence. In Sunfire, the biggest system is We have made mechanical and intelligent warning. In the past, we need to have a business curve like at 10 o'clock. Some of our products have some campaigns. I cannot see very clearly. Actually, there's a gray line. And it is learned data. It can be more accurate when it learns more. This is a very complicated one. I don't want to elaborate. I'm also not an expert for this one. For intelligence, we are working together with professional intelligence people. The biggest benefit is that in the bottom left configuration, it used to be very complicated, but with intelligence, it only needs to enter one column. In the past, during weekends, a 30% drop during weekends is normal because everyone is not working. And during bad weather, there are increase of food deliveries. That is also normal because everyone is ordering food on the internet. So the machine can learn. They can learn about the trends during weekends. So we are trying to test the key businesses of Alibaba, and the results was quite good. Last time. This is my Dingding and WeChat account. If you are interested, you can scan it. The purpose is that if you are really interested in monitoring, you are welcome to discuss with us. I would be more willing to welcome you to join Alibaba, join our team. That's all for today because of time limit. Thank you. Next, let's welcome Zile to talk about how do we create the Double 11 environment. Let's welcome.